7, if the numerator and denominator have a 0 in common, there's going to be a hole in the function's graph. So to graph the function, first you're going to factor, factoring skills, the numerator and denominator. To discover any common factors, you're going to find the hole by evaluating the new function created by canceling the factors at the undefined value. So that's a lot of garble right there. So we're going to first find the new function. So you're going to find the new function by factoring first. So let's factor this baby. How do I factor the numerator? It's a trinomial. So I'm going to use the diamond method, right? I'm looking for the factors of -2 that add up to -1. So what factors do I want to use? -2 times 1. So x minus 2 times x plus 1 is the numerator. All right, denominator, I only have 2 terms. So what strategy should I use? Starts with a G. GCF. What is the GCF of x squared minus 2x? X. And then when you divide both of these terms by x, what would you have left? All right, so something should come out the same, right? Something comes out the same in the numerator and the denominator, that gets canceled. So the function that we are going to look at is actually x plus 1 divided by x. So this is the function. We're going to pretend we're taking a quiz on this function. We're going to graph this, do steps 1, 2, 3, and 4. And at the very end, where's our hole going to be? Where was this undefined? When x was +2. So our hole is going to be in this function when x is 2. So we just pretend that this didn't just happen. This is my function that I'm going to do all of my steps about. So my first step is I find the y-intercept. How do I find the y-intercept? Look at your note card. Plug in 0. And what do you get? Can't do it, right? So there's no y-intercept. Step 2, you're going to find your x-intercept. How do you find your x-intercept? On your note card. That's why you got the note card, to at least practice it the right way. Where will the numerator be 0? Where? What will make the numerator 0? -1. So -1 comma 0 gets plotted on my graph. There it is. All right, step 3 is a vertical asymptote. So I take a peek at the denominator, and what does it tell me? X can't be what? When will the denominator be 0? When x is 0. So I have a vertical asymptote at x equals 0. So that's the reason why there was no y-intercept up here, right? Because that's a vertical asymptote. And then step 4 is thinking about my horizontal asymptote. How do the powers of x's stack up against each other? They're equal in strength, right? Linear divided by linear. So 1 divided by 1, right? Y equals 1. Y equals 1 is a horizontal line right here. So I'm just going to keep graphing just like I used to, just like I needed to on the quiz. Like this was a quiz question with those 4 parts. So I know that one of the elbows goes like this, right? In that quadrant towards each of the asymptotes. I'm guessing that the other elbow is up here in the top right. I could plug in a value. Like if I plug in 1, what do I get? 1 comma 1 plus 1 is 2, divided by 1 is 2. So 1 comma 2 is here, and so the other elbow goes like that. So those are the 4 steps that you had to do on the quiz. That's why I'm saying we're still practicing those 4 steps over and over all week. So I think if you wanted to retake that quiz, you'll be really good at rational functions by the end of this week. Step 5 is the only piece that we're adding in. I canceled something over here. See how I canceled these x minus 2's? So 2 should have been a vertical asymptote, but it got out of being a vertical asymptote. But 2 is still undefined in this original function. So I need to put a hole at 2, comma. When I plug in 2, what do I get? 2 plus 1 is 3 divided by 2. 3/2. So at the point 2, 3/2, there's a hole right there. So you indicate it by putting an open dot on the elbow that you've already drawn. So the only thing that makes this function different than this function, if you had just had this function on the quiz, you would have done steps 1 through 4. We had this function, so it had a hole. We canceled this as our first step. So at the end, step 5, now we have a hole right there. So you're not going to see any difference when you graph these, but I just want to show you. Oops, hold on. I was graphing inequalities in my last class. Okay. So if I type in the original equation, x squared minus x minus 2 divided by x squared minus 2x, and I graph the equation just x plus 1 divided by x. So I'm putting this function in, and I'm putting this canceled function in. If I just graph it, you're going to see the blue line, and then the red line is going to go right on top of it. It's the exact same graph. The only difference, because it's hard to see a hole, the only difference is if I go into my table, in my table, what's the difference in my table? Look, the table's exactly the same, except at 2. So at 2, we have a hole, and on the other graph, we have a coordinate 2, 1.5. So the only difference between the two is the hole at that one point. Everything else is exactly the same. So you're just going to miss that if you don't factor at the beginning. Oops. Breaking my, uh-oh. Oh no. Okay. I'm still recording, still here. All right, number 2 is nicely factored for you. What cancels? Again, the x minus 2's cancel. That's just a coincidence, but my function is now 3 times x minus 5 over x plus 1. So let's go through our steps. What's my y-intercept? What's my x-intercept? My vertical asymptote and my horizontal asymptote, and at the end, I will have a hole. So this is your 5-part steps. You're using your note card as a crutch, but we're memorizing these 5 steps for next week. All right, what's my y-intercept? When I plug in 0, what do I get? No, wait, so 3 times negative 5 over 1. So it's actually negative 15. So negative 15 is off the graph. I would just kind of plot a point down here to remind us that our graph does go through that y-axis eventually. It's just kind of off your graph. All right, what's my x-intercept? Where is the numerator 0? Where? Positive 5. So 5, 0 gets a dot. 1, 2, 3, 4, 5. So I can kind of see that that's going to be an elbow eventually. All right, vertical asymptote, where is the denominator? Undefined. At negative 1, so that's kind of confirming my elbow because it's going to ride this vertical asymptote. And horizontal asymptote, numerator, denominator, do they tie? Where's the power of x? So we have 3x over 1x. So to me, they're both linear functions. So when you strip the coefficients of x, you'd have 3 divided by 1 is 3. So it actually is a horizontal asymptote at y equals 3. So see how that makes this elbow show up? All right, what could I plug in that will confirm that I'm in this top left quadrant? -2. Is that what you said? All right, if I plug in -2, I would get 3 times -7, right? -21 over -1, +21. -2, +21 is way up here off my graph, but it shows me that the elbow is in this region. Where's my hole? Go back to the beginning. What did you cancel out? So where was this denominator originally undefined? +2 for x. What is this value's function when x equals 2? So we're going to plug in 2 over here. 3 times, this would be -3, right? So -9 divided by 3. -9 divided by 3 is -3. Our graph should have gone through 2, -3. I kind of missed it a little bit, but I can kind of spin my, there you go. Maybe you want to find the hole first if you're picky about what your graph looks like. So there should have been a hole on our function at 2, -3. See how the elbow swings right through that point? In your table of values, that one point will be undefined for this function. All right, I'm going to have you try the next two, but some of us are struggling with factoring, so let's get it in factored form first. I like to kind of cheat a little bit if I don't like to factor. If I'm telling you there's a hole, what factor do you think is going to show up in the denominator? Probably 2x minus 1, right? Because it's going to cancel out with something in the denominator. Let's see if I can make 2x minus 1 show up in the denominator. What would the other factor have to be so that binomial times binomial will produce this trinomial? So kind of use the problem to help you. That's another good test taking strategy. What would this binomial have to be so that when I multiply these together, I produce this trinomial? 2x times what will give me 2x squared? X, right? 2x times x. And then if this is a -1, what do I have to multiply by over here to get this last term, +3? -3. And then we can just check that our outer plus our inner will add up to -7x. Don't I get -6x and I get -1x? So see how I can kind of use one of the factors to cheat a little bit? And oh, okay, my 2x minus 1's cancel. Be careful, the x minus 3 is in the denominator. So your function is really 1 over x minus 3. So you're going to use this function to do your y-intercept, your x-intercept, your vertical, and your horizontal asymptote, and then your hole. So in a minute, I'm going to have you come back to example 3 and see if you can use your note card like a quiz question to answer those pieces. Let's factor number 4 together so that you're not struggling on the factoring part. So what do I do to factor the numerator? Starts with a G. Greatest common factor of what? Is your brain starting to see this, or are we still not practiced enough? Divide by 5, and I would have x squared minus 4 left, but that's not fully factored. What's my next step to get it fully factored? Careful, it's x squared minus 4. Did you say 1 or 2? So it should be 5x plus 2x minus 2. So that's my numerator. Now I need to factor the denominator. What can I factor out of the denominator to start with? Greatest common factor of 3. What would I have left? X squared plus 4x plus 4. Are you with me? I'm dividing by 5, then I'm dividing by 3. What's my final answer for factored form here? How do I factor x squared plus 4x plus 4? It's a perfect square trinomial. We've seen this one a lot. X plus what? X plus what? You guys need to get your factoring skills under your belt. This should be screaming at you. How do I factor this trinomial? What are the factors of 4 that add up to 4? X plus 2, x plus 2. One of those x plus 2's cancel out. So the function that I want to answer all my questions about is, 5x minus 2 over 3x plus 2. I would leave it in factored form because it's going to be easier to do your x-intercepts, your vertical asymptotes. Yep. The more you practice, the better you're going to get at this. I know it's hard. When I plug in 0, I get negative 1/3. So 0, comma, negative 1/3. My x-intercept, I can never make that numerator 0, so there is no x-intercept. Denominator, so see how I plug in 0, I look at my numerator by itself, then I look at my denominator by itself. So that will be when x equals 3, vertical asymptote. And then I compare the numerator and the denominator. So this is our first example today, but the denominator has a larger power this time. So that tells me that y equals 0 is my horizontal asymptote, which confirms probably why there was no x-intercept in the first place. So it looks like I've got one elbow down in this bottom region. Probably my other elbow is in this top region, and I can plug in the number 4 to figure that out. If I plug in 4, I get 1 divided by 1, which is 1. 4, comma 1 is right here. That's my other elbow. So then at the very end, you want to make sure that you remember, oh, I canceled something up here, right? I canceled this 2x minus 1 factor. So this was undefined at positive 1/2. Positive 1/2 is kind of hard to plug into this. What's 1 divided by, I'm plugging in a half, so I get negative 2.5 in the denominator. It's negative 0.4. So, I mean, at a half, there's a hole right here at negative 0.4. It's kind of hard to make that exact, but positive a half, it's at negative 0.4. So I put a hole on my graph. So, I mean, are these 4 steps still confusing? This is what you guys need to do those practice problems for on the homework. And then the last one on this page, if you had time, if not, just fill it in now. My y-intercept, let's see, when I plug in 0, I get negative 10 on top divided by positive 6. What's negative 10 divided by 6? Negative 1 2/3. So I needed a calculator for that, but negative 1 2/3 is about here. All right, I look at just the numerator for my x-intercept, so that's at 2, 2 comma 0. I look at just the denominator for my vertical asymptote, so that's at negative 2. And then I compare the numerator and denominator, they tie. So when I strip the coefficients, I get 5/3, y equals 5/3. 5/3 is what? More than 1, but less than 2. So I'm about here. Just less than 2 is my vertical or horizontal asymptote, right? So there's one elbow. I know that it's up here. I'm going to skip plugging in that point just to get to my hole before the bell rings. When I get to the hole, negative 2 should have been the hole, right? Because x plus 2 got canceled. But guess what? The other x plus 2 is still there. So there's actually no hole because a vertical asymptote always overrides a hole anyway. So I can't put a hole on top of a vertical asymptote. So there actually is no hole because the x plus 2 is still sitting there as a vertical asymptote. So I hate